Hi there. So first, let's pop into my dataset. I found my dataset on Kaggle. I believe that you guys are quite familiar with this website. There are various of data. So if you are trying to make a comprehensive machine learning project, Kaggle is definitely worth to try. As we can see, my stroke dataset contains about 5,100 10 observations and 12 columns, and it is supposed to forecast whether a patient is likely to have a stroke. Except for the patient's ID in the first column, each row in the dataset is related to the patient's personal information, with a total of 12 columns. The other 11 columns are related to prediction parameters such as gender, age, hypertension, heart disease, marital status, type of work, place of residence, average blood sugar level, body mass index, smoking status, and whether there is a history of previous stroke illness. Since the first column ID will not provide any useful information, so we remove it for the stroke dataset. What I'm trying to predict is in the project, we would like to predict if a patient is likely to get a stroke based on the provided parameters. And this is how I explore the data. So first of all, I check the distribution of all numerical variables in my data set. It clearly shows that the age, average growth level, and the BMI are the only three numerical variables in the dataset. The BMI and average variable and age variables are already normal distributed. So we have no need to normalize these two variables. The BMI and age variables are already normal distributed. So according to the plot, we can see that the log average glucose level is distributed as skewed to the right, while the age and the BMI, these two features appear normal distribution. Other variables in the dataset are dummy variables in coding. So here's the code briefly shows how I transformation the and do the normalization. First, I normalize the variable average growth level by doing a square root transformation. Then I normalize the variable by doing the log transformation. After that, I compare these two methods. So based on the plot, we can see that the log transformation is distributed as a skew to the right, while the age and the BMI features appear to normal distribution. Other variables in the dataset are dummy variable encoding. Then I check the categorical variables. So in my project, I built 4 models. The first one is logistic regression. The second one is naive Bayes classification. The third one is support vector machine model. And the last one is decision tree. So why I pick this model? Because for the first model, the logistic regression is intended for the classification and is particularly beneficial for analyzing the impact of multiple independent variables on a single dependent variable. And for the naive Bayes approach, it takes only a minimum quantity of training data to estimate the required parameters. So it is suitable for the little data set of 5,110 entries. At the same time, when compared to other algorithm, the algorithm is exceptionally quick. And for the third model, support vector machine. It is a binary classification model. Its fundamental model is a linear classifier with a widest interval established in the feature space, which is the most distinguishable from the perception. And the last one is decision tree. It is really easy to comprehend and deficit, and it only necessitates minimal data preparation. Both numerical and categorical data could be handled by this technique. So here how the model perform. As we can see, this brief code shows how my model performed. The first one is logistic regression. And the second one is naive Bayes classification. Third one is SVM. And the last one is decision tree. Now let's pop into the how I evaluate my model. I evaluate my model based on the accuracy. As we can see in the output, the logistic regression had 78.74%, which is pretty low compared with other three models. There are 14 people are false have stroke and 299 people are false not have stroke. Second one is naive Bayes classification. It has a 89.74% accuracy with 37 people are false have stroke and 114 individuals are false not have stroke. So the third one is the SVM. As we can see, that the classifier correctly identified letter in 1,410 of the 1,472 test data. Our model has a 95.788% accuracy, which is pretty good. And the last one is also the has the best performance of all our models. It has 95.79% accuracy, which is pretty good. So after that, I assembled my model together. I pick 3 predictive models, which is decision tree, logistic regression, and naive Bayes. And I assemble these 3 models to predict if an individual will have a stroke or not. If the 2 models disagree on the prediction, the prediction from the model with a higher accuracy should be adapted. Here is a briefly shows how well the model performed. As we can see, I made a prediction whether age of 51 married male who lived in an urban region with a private job and smoked and had hypertension but no heart disease, had an average glucose level of 5.75 and a BMI of 25 is likely to have a stroke or not using the ensemble model above. According to the output of my ensemble model, the individual would not have a stroke according to the output. As we can see, the output is X0, which means there may be a divergence because our model does not have 100% accuracy, but based on our ensemble model, our prediction is the patient would not have stroke, would not likely to have stroke. And my ensemble model performed pretty good because no model disagree with the prediction. all three models had the same result on the prediction. And here are the summary and the key lessons that I learned. So overall, through the modeling and the comparison of the 5,110 stroke data set, we come to the conclusion that the decision tree is the best prediction model, which we could obtain the accuracy of predictions as high as 95.79%. By adopting the prediction results of the decision tree model, doctors can quickly and accurately predict whether a patient will have a stroke in the future, which will greatly improve the efficiency of hospitals. Thank you. Thank you for listening. This is my presentation.